Take a look at this video. This is the original front-facing shot. Now I move the camera position higher and then shift it slightly to the right. Pay attention here, this is not cropping, and it is not just getting lucky by generating a similar video. Both shots come from the same reference video. Today, we'll use the LTX 2.3 model to add a virtual camera to a video that has already been shot. With this camera, you can freely switch viewpoints. This involves a technique called CrossView. It is a LoRa. It uses the entire original video as reference, then follows a camera prompt and regenerates the same performance from another position. Let me give you the conclusion first. For a fixed camera single-shot video with a clear subject, changes to the left, right, higher, lower, closer, and farther can all show obvious differences. But this is not 3D reconstruction. The larger the angle change, the more easily the scene and objects get reinterpreted. And if the original camera is already moving, directional control also becomes weaker. The model we're using today is an IC-LoRa called CrossView. It is based on LTX 2.3. We can give it a reference video without needing any additional first frame image and then give it a prompt. This prompt has a fixed format. Just like what you see here, we call it a fixed 3-axis format. The first position controls whether the camera moves around the subject to the left or to the right. The second controls the overall height. The third controls the distance. In total, there are 63 combinations, and honestly, that is basically enough. When you use it, try to use the official original words. Don't create your own words casually. For easier demonstration, I also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a very solid online workflow platform because whenever a new model or new extension appears, it follows up right away. Running Hub also provides an online communication platform for ComfyUI creators, where you can find a lot of creative inspiration and example workflows. This workflow is mainly divided into two stages. The first stage is responsible for generating a new camera angle based on the reference video. The second stage, pay attention here, is upscaling. But it is not ordinary upscaling. So no matter how large you set the resolution, it will process it in tiles. Alright, now let's break down this workflow. There are quite a lot of nodes, but if we really want to understand it, there are roughly 5 parts. First, we need to upload the reference video. Here, we'll first use this video, which we'll call the Rainy Night Female Swordswoman. Below that is the main model loading. What we need to emphasize here is that we use the version 1.1 main model, along with the CrossView LoRa we're talking about today. For CrossView LoRa, I use 1.5. In the official description, the recommended strength range for this LoRa is 0.6 to 1.5. Next is the prompt. You must write it strictly according to the prompt rules we mentioned. In addition, we also prepare a second prompt. Its main function is not to change the camera angle, but to serve the second stage upscale. Because the second stage upscale will resample the video, and we do not currently have any other constraint. We can only rely on the prompt to keep it as close as possible to the original video. This second prompt is basically a content consistency anchor, so the upscaled video stays as close as possible to the original video. So make sure you understand the division of labor between these two prompts. The first stage changes the camera position. The second stage is the tiled upscaling mechanism. Here, we first upscale the latent by 2 times, and then use tiled latent sampler to reconstruct the details once. Everything else can stay consistent with the original workflow. Now take a look. This is the original video, a shot of a female warrior swinging a sword on a rainy night. And this is the video from a left side camera position. The character and the palace in the rainy night are still there, but the camera is no longer in the front. So the first camera position change is successful. Next, we only modify the camera position. Among the 3 axes, let's first look at left and right. We change to the left in the prompt to the right. You'll notice that left and right here refer to the camera moving around the subject. It does not mean making the character move left or right. The result is also not simply a mirror image. The character position, plants, palace gate, and ground reflections are all reorganized. It will not be perfectly symmetrical like an accurate 3D scene, but it is already very practical for editing into 3 camera positions, left, center, and right. What is the second axis? It is distance. Let's look at the original video. A beautiful woman is walking inside an ancient style building with the same angle and same height. We only change the last item. For example, we change closer to further. You'll notice that the whole shot is pulled farther back. The character becomes smaller, more of the corridor and pool are revealed, and the distant background is filled in more naturally. Of course, moving the camera closer is also effective, but sometimes it feels more like recropping and zooming. So its effect when filling in a farther view is usually more stable than generating a strictly matched close-up. The third axis is height. Take a look. This is the original video, a female elf in a forest. We can adjust it to a low camera position or a high camera position. The low camera position reduces the amount of ground magic circle visible, and the character and wings feel more like they are being viewed from below. The high camera position increases the proportion of the ground and the top-down relationship becomes very obvious. Of course, we can combine all three axes. We can move to the right, raise the camera, and move closer at the same time. So if this is a virtual camera, then it has already learned how to orbit, move forward and backward, and rise and lower. Next, let's see how it performs in complex scenes. Below is a robot scene. The robotic arm switches to different foreground positions, while the robot and laboratory are still preserved. Next, let's look at a more complex scene. This is a two-character scene. The woman in black and the silver-haired woman in red do not obviously swap identities, but you'll notice that in the two examples above, details like the robotic arm, the arm movement, and the fan movement are not copied strictly frame by frame. Now, let's look at complex motion. For the flying dancer, which is this group below, the result is the best. You'll notice that the character's rotation, the colorful ribbons, and the Dunhuang cave are all still there. But the camera has already moved higher and shifted to the side. If you bring a shot like this back into the original video, you'll find that the overall sense of motion becomes much better. When building scenes, if it is this kind of grand scene, I think changing the camera position works well. But if you are describing a commercial product, you need to use CrossView very carefully, because when it changes the camera angle, it can also change product details. If a medium angle is not enough, can we generate twice in a row and let the camera keep changing? Let's look at the example below. This is a Phoenix Priestess scene. In the first step, we use this method called R to the right. We pull the camera farther away, and also move it to the right, orbiting around the shot. You'll notice that the angle change is quite obvious. The Priestess, Phoenix, and Stone Arch are all still there. Now let's look at another route. First, we move it to the right once. Then we use that result as the new reference and continue moving it to the right again. At this point, you'll notice that the camera does indeed move again, but the Phoenix gradually turns into a vertical flame. The character proportions, Stone Arch, and the whole altar are also changing. The reason is very simple. The previous round generated not only a new angle, but also new errors. The second round treats those errors as the real scene and keeps generating from them. So small step chaining is not necessarily better because it can continuously amplify errors. If one step can already generate a large enough angle change, then just generate it in one step. If one step clearly causes the result to break, then you can try a two-step chained approach. Next, pay attention to a very important issue. If the camera in the original video is not fixed and is already moving by itself, this has a big impact on the overall result. This video uses a side tracking shot, and the background already has clear parallax. Now we use CrossView to move slightly left or slightly right. Looking at them separately, you'll notice that both videos can preserve the main actions, like running and jumping. But once you put them side by side, you'll find that the difference between left and right is very small. That is because the original video has already clearly told the model that the camera is moving sideways, while CrossView is also asking it to choose a new camera position. When the information from two cameras overlaps, directional control becomes quite ambiguous. So if you want to create a second camera angle, the original video is best shot with a locked camera. When you actually use CrossView, the first thing to focus on is how to write the prompt. The second is to start with a medium angle. Also, try to choose original videos with a fixed camera position, a single shot, and a continuously visible subject. Alright, that's all for today. What are you waiting for? Go try it yourself. Follow me and become someone who truly understands AI.